All right, so again, my name is Jessica Brooks, and I'm facilitating the guest speaker series today. I'm going to turn it over now to Phil Schumacher to do some introductions for our talk today.
Okay, thanks, Jessica. And thanks everyone for attending today. I'm very excited to share this talk with you. This is actually a culmination of work that Kevin Gallo, Dr. Kevin Gallo from NESIS and I have been working on for over 10 years actually. And we're excited to be able to share information with you on how you can actually quickly identify hail swaths. And so this is actually the work that we're sharing today is work done by Mark Bruin. He is a senior at Iowa State University, and he was a Holling Scholar at our office here in Sioux Falls during the summer of 2022. Mark is a whiz at ArcGIS and ArcGIS Pro and Python, and he was able to write a program that basically will ingest mesh data, satellite data, and warnings, and provide you information on where there are potential hail swaths with severe storms in your area that you can then use to help verify warnings at a later date, or to look at those storms in more closely at a later date and time as well. So Mark is going to be finishing up his senior year here at Iowa State in spring, and then is looking to go to graduate school somewhere in the Midwest, I believe. He can correct me if I'm wrong. He's still waiting for responses. So any school that gets him, I think, will be extremely lucky, and Mark will have a great career in graduate school and beyond. So with that, I will turn it over to Mark to begin the talk.
Great, thank you, Phil, for the introduction. So my talk here is called Automation of GOES-16 ABI Data to Assess Hail Swath Vegetation Damage and Severe Warning Verification. And like Phil said, this was for my Hollings project that I did over the summer. So real briefly, to just outline what we're going over, going to go over objectives of the project this summer, background on what hail swaths are and how we look at them on satellite, the methodology that we used for the program that we designed, using the program as forecasters at the Weather Service, and then benefits of using the program, and then limitations that it has, and next steps and where we go from here. So first off, GOES-16 ABI can be used to identify areas of hail damage to vegetations, and so that's research that has been done previously by my mentors, Phil and Kevin, and we discovered this summer that it can be automated using Python. And so our end goal here is to be able to create an interface for NWS employees so that they can verify severe thunderstorm warnings and then also improve documentation of hail damage using this program that we've designed. And so real quick preview here, right side at the top right there, that is an image of what the UI looks like when you open up this program. And then once you've brought everything into ArcGIS, you get this nice 4-panel display of data like what is in the bottom right there. So real quick here, background on what these hail swaths are on GOES-16. So to detect these vegetation changes, we use an NDVI, which is really just a measure of vegetation health or vegetation greenness, and it uses ABI bands 2 and 3 to make that calculation. And so what we're really doing here is we're taking the NDVI 7 to 14 days after a storm has passed, and we are subtracting the NDVI before the storm has passed. And so when we do that subtraction, we get the total vegetation change through that period, and often it's due to storm damage. So at the bottom here, we have our band 2 and our band 3 images, and then we create that NDVI. And then here is our pre-storm NDVI, and then our post-storm NDVI. And so before the storm, you don't see any sort of hail swath here, but after the storm, that starts to show up, and then our NDVI change on the right side here, we get in green, anywhere where vegetation health greenness has increased, anywhere in sort of the yellows or browns is where we saw a decrease through that period. And so we actually have two hail swaths from 2 different days showing up in this particular image. So we then want to take it one step farther than just getting that image, and we also want to automatically isolate where those damaged swaths are. And so to do that, we use 2 criteria. One is our POD criteria, where we're trying to maximize the probability of detection, and the other one is the FAR, false alarm rate criteria, where we're trying to minimize that. And so when we set different thresholds for isolating that hail swath damage, we want one to be sort of prioritizing that POD and one to be prioritizing that FAR. And so those thresholds are going to end up being set in different places. But basically, any pixel on that NDVI change image that passes those thresholds or those tests are going to be identified as a hail swath. And so until now, this was really rigorous and time consuming, could have taken up to an hour or more, where you have to manually download all of this data, reformat it, find clear sky days, and run everything in ArcGIS or R scripts, Python, just a lot of stuff that had to happen manually to make this happen for just one day. But now we have created what we've called the automated assessment of hail swaths. It does everything in a single Python script that runs via ArcGIS. And so this is the GUI here. So you can enter an event date and a sector that you want to view, and all of the data is downloaded automatically, turned into shapefiles, and can be viewed easily within ArcGIS. So I want to go into more detail here about the process of what the program actually is doing when you're running any of these cases. So for the pre-storm image that I was talking about earlier, we use a 7-day NDVI maximum. And so that really allows us to eliminate all cloud cover from before the storm happened. So because that's one thing that is a real challenge in making this project possible, is how do you deal with all of this cloud cover that is constantly showing up on satellite, because we want to see the ground for this project. So that's how we deal with that pre-storm image. Now for the post-storm image, we have to do it a little bit differently. So we look in the 7 to 14 day range after the storm, and the script will look at the total sum of cloud cover pixels during that, for each day during that period, and it will pick the day with the most clear skies. And then it's also on that day going to go through midday, hour by hour, and select the best hour, because that can change quite drastically too from hour to hour. So really it's automatically selecting the best day after the storm where you have the most clear skies. And then more detail on how we isolate those hail swaths now. So like I said earlier, every pixel has to pass this threshold, and the first threshold that we use is a mesh threshold. So you're looking at estimated hail size on radar. So this on the left here, this is like our NDVI change map that we have, like I showed earlier. And so when we apply a threshold, in this case, the POD threshold, so that's going to be a 22.5 millimeter, where anywhere where mesh was estimated to be above 22.5 millimeters is going to be kept and passes this threshold. And so when you do that, you end up with a map that looks something like this. And so we're getting closer to isolating where these hail swaths are, but we still have a lot of areas in there, like anywhere where it's green, where there's not actually any hail damage that occurred there. We want this area here, where all of those darker browns are showing up, to be isolated on its own. And so the next thing that we have to do is say, let's keep all of those really largely negative values and get rid of all of those positive values so that we can isolate that swath. So to do that, we know that land use is going to affect the NDVI change differently. So in big cities, you're not going to expect to see hardly any NDVI change through that period because there's no vegetation there in the first place. But out in like cornfields in the summer, that corn is growing really quickly. Its NDVI is going to be changing quite quickly from day to day, and so those differences are going to make us set those thresholds differently. So what we're doing is we are calculating the quantile for every land use category. So in this case, the POD quantile 0.09 is what we used here. And so for every, say, corn pixel, it takes the distribution of NDVI values for all of those corn land use pixels, finds the 0.09 quantile, and really it uses that as a threshold, and really you're keeping the most extreme negative NDVI values. And so when you do that for all of the land use categories, you set all of those different thresholds, then you're left with just this area, like on the right here, where you have just those areas where that NDVI has changed by a lot in the negative direction. So really we're left here with a hail swath, and all the other pixels have kind of been eliminated. And so the program will do this all automatically. So this is what it looks like if you actually bring it into ArcGIS using the instructions that we've included with the program. So you get these hail swaths that you have our two different criteria here. In red is the POD criteria, so it's sort of a less stringent criteria, and you're going to get more pixels. The blue is more of a strict criteria, so you're going to get less pixels, but either way you have both of those outlining this hail swath, in this case in northeast South Dakota. And then other things that get downloaded by the program are LSRs, severe thunderstorm warnings, and I also mapped out damage tags in this specific example. So as far as using the program as people within NOAA, why should you use it? Well, it provides a way to verify warnings beyond just what you have from LSRs, and can help improve awareness of different impacts, especially if this happens, say, out where it's not very populated areas. You get tons of crop damage and maybe you don't even hear about it. It can help you improving forecasting of damaging hail. If you see that this happened and you go back retrospectively and take a look at what sort of radar signatures were there, what sort of severe storm parameters were in place for that day, and you can line that up with what actually happened and help improve your forecasting. And then lastly, this would be something that you could put into, say, like a story map within ArcGIS Online to help you visualize what actually happened for the public. So if you want to go and download the program, I have it linked here. I don't know if this presentation gets sent out, but I think it's recorded. If not, you can contact me or Phil. And then this drive folder that we have includes previous research, so you can read about more details of how we came to this point, instructions on how to use the program, and then obviously the program zip folder. So if you download it and now you've opened up the program, you've begun running it, using it is as easy as entering a date and a sector that you want to look at. So I added a feature where central region CWAs are going to be available as predefined sectors that you can just enter that ID, and that's the data that it will generate for you over your CWA. But you also have the option to use lat/lon coordinate bounds. So then there's the date entry, and I also added post-event controls because we found that the 7 to 14 day range is the most favorable for getting the best visual of those hail swaths. However, we recognize that there's usefulness in running this, earlier, and you don't have to wait a full week after the event to be able to run this. Like, you may want to run it immediately after, like in the days following the event, and that might be most useful for you. And so, especially if it's a really large, like an event that has really clear damage, it's going to show up in that 2 to 6 day range anyway. So wanted to make that available to the forecasters that are using this. So then the program will run, generate all of these shape files for you. Usually takes about 3 minutes, 3 to 5 minutes maybe is what I've had in my experience. But that's going to be really contingent on what your download speeds are at your office. But so you get all of those shape files are generated, and you can pull up our instructions that we have about how to bring this into ArcGIS and arrange it like the pictures that I have here. But there's like a pre-made ArcGIS project that you can bring those shape files into. And when you do, you get this nice 4-panel display where you have your NDVI difference map here in the top left. Top right, you have your different detected hail swaths by the different criteria, and then you have your severe thunderstorm warnings and LSRs. Bottom left, you can display the mesh data so that you can be kind of aware of what the radar estimated the hail size to be, and then you can also display the crop data layer with all of that crop information in the bottom right. And then worth mentioning also is the applications beyond just hail swaths. So, any sort of crop damage is going to be detected using the program, even though it's designed to only isolate hail swaths. The NDVI change maps still provide you some information with where there may have been damage from other hazards. So in this case, with tornadoes, if you get a particularly wide tornado, they can actually show up pretty well on these NDVI change maps. So this one in the left here, this was an example from the Bassfield, Mississippi case in 2020, where there's actually 4 different tornado tracks showing up here on this NDVI change map. And so, I suppose if you live in sort of like a forested area, if your office has a lot of dense forests and a tornado goes through that is kind of had a long track or had a decent amount of width to it, you can use this tool to quickly generate those NDVI change maps and really see the whole track of it. And then same sort of goes for for severe winds. So this was from the 2020 derecho in central Iowa. You can see it's not quite as clear in some places for the severe wind, but out here on the right side of this image is Cedar Rapids, and you can see where it kind of goes into some yellows or browns where there was corn that was damaged from all of that severe wind. And then you have some more clear swaths showing up really northeast of Ames and southwest of Ames, where there may have been some hail mixed in with all of that severe wind, and so that ends up showing up more clearly. So there are other uses for it as well. But then there are some limitations to what this program can do. So it's going to be constrained by presence of healthy green vegetation. So any areas where you don't have hailstorms coinciding with green vegetation, you're not going to find hail swaths. So, you know, usually southern plains or the southeast where it's more forested and less crops, it's not going to show up as clearly. And then also drought, harvest, disease, crops maturing can all make it unclear whether a hail swath has actually occurred. And so this is a case from southern Kansas where there was a good deal of large hail reports, and that is showing up a little bit on the mesh as well. And if you look in the top left here, there's all of these areas of like scattered browning. And so I'm not an expert on agriculture by any means, but whatever was planted out there, wheat or whatever that may be, is browning as it reaches maturity towards the early summer, and is appearing as a strong negative NDVI change. And so when that overlaps with those mesh swaths, then that can get identified as a hail swath by the program. And it did. In this top right image here, you have all of these little dots showing up that seem like they might be a hail swath, but if you look at the NDVI change image, there's really no semblance of a hail swath actually there, and probably no major damage that occurred with this event. So you just have to be kind of careful when you're looking at it. It's important to see all of the data. Then there's also some cloud mask, I guess I would call it inaccuracies with GOES-16. Because we found that when you have fair weather cumulus clouds, then those individual clouds are smaller than the resolution of the cloud mask, which the program uses. So the cloud mask, I think, is on a 2-kilometer resolution, whereas some of these fair weather cumulus clouds are going to be less than 0.5 kilometer in width. And so they're not going to be caught for that cloud mask. So here's an example where you have, I think this is generally the Sioux Falls area. You have a lot of fair weather cumulus in place, but only a few pixels are identified as being clouds. And so not only is that going to tell the program that this is a clear sky day, but you're also going to get large, like individual pixels of very large NDVI change, because those clouds contribute to big NDVI changes. And so in this case, that overlapped with a hail swath that went through Sioux Falls and identified a whole bunch of pixels as hail swaths, even though if you look at the NDVI change map, it's really kind of unclear whether or not there's any sort of hail damage there because of all of the fair weather cumulus that are getting mixed into that. So really, I mean, my advice on actually interpreting this data is you're just looking for areas where all of these identified points are packed together or continuous. Like anywhere where it's dense and continuous is probably a real hail swath. And in this case, it's all scattered around and very clearly more from the cloud cover than any hail damage. So going from here, the NWS Central Region approved the program back in August, and can now be distributed to offices across the Central Region. Towards the end of my project, we were also working on developing for compatibility with ArcGIS. There was a big ArcGIS 3.0 update that came out right at the end of my project, and so we ended up making 2 different versions of the program, one for anybody still running in ArcGIS 2.9 and one for anybody running in 3.0. And so those 2 versions exist. Most I'm sure most offices by this point are probably on ArcGIS 3.0, so we have that available to you. And as of right now, the latest version doesn't download severe thunderstorm warnings because there was a Python package incompatibility that we were hoping would get fixed by now. But we'll see what actually ends up happening with it. That's not a major issue at this point. And then also the main thing that we're hoping to kind of achieve with this is revisit LSRs and verifying severe thunderstorm warnings. So here's an example from Southwest North Dakota, where you had this really long hail swath that caused a lot of damage across a couple different counties there, and only a few hail LSRs at the very start of that swath, and no hail LSRs through really all of that main part of the swath where all that damage occurred. And so, if those warnings were only verified by hail LSRs, they wouldn't be able to even verify those warnings. And so there's clearly got to be a lot of cases like this where the hail LSRs that are actually entered and found are not really representative of this really long continuous swath of hail that occurred. So that's kind of what we're pushing for in the future, is to better document what has actually happened. And then a couple other directions that we can go with this is looking at mesoscale and storm scale. So, mesoanalysis parameters, soundings, radar scans that happened during these hail events, and what sort of conditions may create specifically these damaging hail conditions. Because I forgot to explain earlier, but this damaging hail is the result of not just large hail, but also it being wind-driven or it occurring in high volumes. So there's a lot of different factors that go into actually creating a damaging hail swath. And then it'd also be good to study severe storm warning verification, and how well, like the last slide, how well those warnings are actually doing with these hail swaths. And another topic that I personally find really interesting, so I threw it in there, is how hail swaths affect the bone ratio, and how that can affect the weather around it, or possibly even initiates thunderstorms. That was a paper done a long time ago that I think was really interesting. And then impacts on other land cover types. Like I talked about how crops are showing up really well on NDVI change, grasslands can as well, but then forests and really all of the southeast and eastern United States, where hail is still occurring, but how well is that actually going to show up on the NDVI change maps? So we found that NDVI change can be created and hail swaths identified automatically for a given date with limitations. And this is going to be incorporated into a program that can be used by NWS offices to help them verify warnings and improve documentation. And this process opens up the door to new research. And then one other thing that I wanted to mention was sort of in its early stages right now. It's not like you can see these swaths and just go straight to verifying damage, because it's not proven to be that reliable that you can just go and verify a warning from it. But in its early stages right now, you can use that information of knowing where those hail swaths are to go down the list of calling storm spotters or emergency managers or whoever else in the area to try to add more LSRs to help you verify those warnings. So I want to thank Daryl Herzman at Iowa State for really making this new mesh archive for us to be able to use for this. And then a whole list of NWS staff who volunteered to help test this program. And then also special thanks to my mentors, Phil Schumacher and Kevin Gallo, and the funding sponsor, which was the NOAA Hollings program for funding this project. And I have some references in here, and I can take questions now.
All right, awesome. Thank you so much, Mark. It was a great presentation. A lot of really awesome stuff that you did. Anyone who does have questions, I will unmute you or attempt to unmute you, and we'll try to get you to verbalize your comments for Mark. I see Matt Bunkers has a question. So Matt, go ahead.
Yeah, thanks, Mark, for the presentation. I really liked it. I was wondering if you could back up a few slides. I just have a question on where you show the POD and the FAR, what kind of with your image that shows the hail swaths. I think it was like 7 or so slides ago. Yeah, so right here. Well, go.
Is it this one or?
Well, I guess it could be that one too, but go forward one more. It was a little bit easier to see. Yes, right here, revisiting hail LSRs. So I see, you got a lot of red and blue pixels there. I mean, how are we supposed to interpret that with the FAR? What's the FAR telling us that you really there isn't a hail swath signature there, or really? I guess I'm not sure what to take away from that.
Sure. So, in my experience from looking at a lot of these, how I would interpret this is, so when if you're deciding whether or not there is a hail swath, I would use the FAR criteria because it's a little more strict, and if there is in fact a hail swath, it's going to pass those more strict criteria. So, the FAR prioritizing false alarm rate, it's trying to keep you from adding in any pixels there that are false positives. So if you're trying to decide if there is in fact a hail swath there, the FAR is what you really want to be looking at. Now, if you know that there is a hail swath there, it's very clearly there. I think that the POD criteria is really better representative of finding that whole swath. So in this case, I think it's fairly reliable to look at those red points, those POD criteria, and be able to say that, yeah, that is probably more representative of how long that swath actually is. Because I mean, if I had the information on here of the NDVI change, it would be fairly obvious where it has dropped down from that storm damage, and that gets detected on the edges here only by the POD criteria. So both of them kind of have different applications and different uses within this program, but both criteria there are there to help you navigate sort of the limitation challenges we have with looking at this data. Does that kind of answer the question?
Yeah, perfect. That's exactly what I was looking for. And then I just have one other quick question. What was your criteria again for filtering out clouds?
Yes, let's see here. Yeah, so this is, if I actually had an output in the program, this is what it would look like going through the logic of selecting those clear sky days. So again, the pre-storm image that we use is a 7-day NDVI maximum. And so, because clouds are going to cause low NDVI, and so that's why we can use it for the pre-storm image. And so that will really eliminate pretty much all cloud cover most of the time for the pre-storm image. Then the post-storm image causes a little more of a complication because if clouds cause low NDVI, then what you actually want is you want to see NDVI changes. So you can't use an NDVI maximum for the second image. It's not going to show up as clearly. So the post-storm image, if you have the 7 to 14 day selected, like in the GUI, then it will go through those 7 days in that range, and for every day, it's going to look for the lowest number of clouds in that cloud mask over your area. So in this case, if you look in this image on the right, it selected day 14 in that period, which had 664 total cloud pixels, which was significantly less than the other days, which had on the order of several thousand, even up to 10,000. So it selected that day, and then it will go through 15 to 20Z because it wants that midday time period where that NDVI change is going to show up best. So then it will go through those hours and select the best hour. So then in doing that, it selects hour 19 in this case, where it gets all the way down to only 18 total pixels of clouds. And so your final image is really going to have hardly any clouds in it because of this logic that it goes through.
Okay, yeah, just one follow-up. So like your cloud pixel sum, what are you using to determine that? I mean, what are you using, the red band visible or an NDVI value for that particular date?
Right, so the cloud mask is a product that is already stored with all of the rest of the GOES data. So like in the AWS archive, you can download band 3, band 2, a whole bunch of other stuff, but then another product that you can download is the cloud mask. And so that's what it uses is that product. We don't generate anything within the code that identifies clouds.
Gotcha. That's what I was wondering. Thanks very much.
Yeah.
Thanks for your question, Matt. We'll say too, if somebody wants to put a question in the question box and type it in rather than voice your question, please do that too. Otherwise, Aaron Johnson has a question. So you should be unmuted, Aaron.
Okay, can you guys hear me fine?
Yes.
Yes.
All right, well, excellent talk. Great use of, I guess, really what the satellite data provides us. I do have a question though, and maybe I glossed over this. So especially when it piqued my curiosity when you mentioned LSRs and hail size, is there some type of filtering you do based off of these hail swaths when you get wind-driven small hail? Because for example, in the winter and spring wheat regions that are more prevalent in the high plains, you do not necessarily get 1 inch plus diameter hail in these regions where the wheat can be absolutely mowed by 60, 70 mile an hour winds plus small hail. Is there some type of filtering that can actually do a better job? Because mesh by itself can really be horrible at times. So I guess I was curious if there's some process, because the hail swath, I've seen this within the data, the hail swath will look identical for a small hail but wind-driven event for these wheat dominant regions versus larger hail.
Yeah. I mean that brings up a good point, because the cases that the mesh criteria that we set, the cases were based on damage surveys of, I think, a few storms in South Dakota, and my mentors would be able to talk in more detail about this. But if there is a case where that's really small hail below our criteria comes and does all of this damage, it's not going to be detected as a hail swath. And so that's kind of why I wanted to have the NDVI change also displayed with the rest of the data, so that if that does happen, and I think it would be more of a rare case, but I'm sure it could happen. Like you said, if you have grasslands mowed down by hail that's a little bit smaller than 1 inch wide, then that's not going to get detected. So having that NDVI change map available is sort of your tool to be able to still see where those hail swaths are, even if it doesn't get automatically detected by the program. And then if we did end up lowering the threshold to cope with that, then we're going to end up getting a lot more false positives. And so that's kind of the challenge that we're working with here. And if you wanted to know more about how we set those particular thresholds, I would defer to my mentors, Phil and Kevin.
Okay, thank you. Yeah, it's just interesting because a lot of our larger small hail accumulating events, the mesh will pump out 2-inch diameter hail, and we can't even get a single dime size hail report out of these. And so they're just a large volume of small hail that's wind driven, and it'll mow the winter spring wheat crops. So, MES by itself, unless there's some type of correction or bias put in there, can really be misleading for a trigger. So anyway, thank you. Very good.
Yeah.
All right, thanks. Is there any other questions that anyone has, or any other comments from Phil or Kevin?
Yeah, first of all, great job, Mark. This is Phil. And Aaron, we would be very interested in additional cases. Like you said, there are issues with mesh not being accurate all the time. We've seen that up here in the exact same type of cases you've described, where we get lots of small hail. And as Mark said, it's not going to detect it if the mesh is too low. It will detect it if the mesh is overestimating. And like you said, it will just detect the damage. What we did, I would be happy to describe the process we did to set those thresholds. They're based on 4 cases that we surveyed back in 2014. We're hoping that this will be useful. One of the things we're hoping to do is possibly work with some researchers in the future too, where this would be utilized, and then they could compare the damage and hail size and wind speed to what we're showing and see how accurate it is. And if we do need to consider smaller hail in some way as well.
Hey, this is Kevin. Yes, let me add, great presentation, Mark. On that last topic, as the slide shows and tries to caution, land use does affect NDVI change, and Mark did mention that at times during the presentation. And the wind-driven hail, the smaller size is definitely something that could be a great additional Hollings topic for a Weather Service location in that environment to follow up on what's been done thus far. As Phil mentioned, there's definitely some additional input that would be useful to make it more applicable to other regions. So it might be something to consider.
All right. Well, I will give one last chance for questions. Anyone? And if not, we'll be getting Mark's presentation, and this again is recorded and will be put on the CR guest speaker series page for additional viewing for anyone, your staff, and whatnot. But again, thank you, Mark, for coming. I think this will be a game changer, and can get some really good information moving forward here as offices start using it. So thanks again, and otherwise I'll let you all get the rest of your day back. So thanks again, and have a great rest of your day.
Thank you.
Thanks, Jessica.